Okay, hi everybody. We're going to wrap up this introduction to the moles by talking about a concept called molarity. Molarity has to do with solutions and how concentrated a solution is. In our labs, you might not know what it meant. You've seen that we have, for example, 1 molar hydrochloric acid. Well, what does that big M mean, 1 molar hydrochloric acid? That's what we're going to figure out. Okay, so solutions. These are some things you need to know. We mentioned solutions in our very first unit. A solution is a homogeneous mixture. That means that they're evenly distributed throughout of 2 or more chemicals. They have dissolved in that. So Kool-Aid, for example, is a homogeneous mixture. It's a solution. The solute is the chemical that is dissolved. So for example, with Kool-Aid, sugar would be the solute, and then the solvent is whatever's doing the dissolving. 99.999% of the time, the solvent is actually water. We call water the universal solvent. Almost everything in chemistry is dissolved in water when it's a solution. All right, and you need to know those terms, so write them down as needed. Pause me whenever you need to. Okay, so solutions, we can't just put it on a scale and know how concentrated a particular solution of pop or Kool-Aid or coffee or whatever is. So in order to do that, we have to be able to state the concentration of the solution in our calculations. We don't normally do that with Kool-Aid, but with our acids and bases, we really need to say how concentrated they are. Concentration tells me how dangerous they are. So if I have a 0.5 molar concentration of hydrochloric acid and I get it on my skin, I'm going to wash it off, but I'm not worried. If I get 12 molar hydrochloric acid on my skin, I'm going to get a burn faster than I have time to wash it off. So the concentration is super important. All right, so how do we calculate concentration? It's how much solute is dissolved in an amount of solvent. That's what concentration is. Write it down. There's a bunch of things you need to write down here. The unit that we're going to use is called molarity, and it's always a capital M. And that's important because in metrics, we use a lowercase m for meters. So you have to make molarity a capital M. So the way that we write it is it's moles of solute per liter of solution. But wait just a second because I'll give you a faster way to write that. I'll give you the formula for it. So remember that we've learned in the past the formula for density. Density equals mass over volume. Well, molarity is the exact same kind of equation, and this is what I want you to write down. Molarity is the number of moles over liters. Now, again, notice molarity is written with a capital M. Moles doesn't have an abbreviation, so you can't write a little m and mean moles because that's meters. So about the only abbreviation I've ever seen for moles is MOL, and that's not much of an abbreviation for such a short word. And then liters is actually supposed to be capitalized. So here's another way of writing that equation. So capital M, number of moles over number of liters. And so then it says, whoops, let me get that out of the way. There we go. Isolate the variable that you need. So you want the variable that you're looking for. Let's say you're looking for number of liters in a particular problem. It's on the bottom. So somehow I've got to get the number of liters on the top and all by itself, not with any of the others. So that's using your algebra to get it isolated. And we have done that kind of math before. So we'll give you a little example problem here. And again, I need to get myself out of the way. Always in the way, right? There we go. Okay, so let's try this problem. It says, how many grams of sugar, C11H22O11, are dissolved in 1.2 liters of a 2.50 molar solution? Wow, that's a lot. Okay, so for one thing, anytime that I see molarity, also called molar, M-O-L-A-R, capital M, I know that it means moles over liters. So I can rewrite 2.5 capital M as 2.5 moles in 1 liter if I need to. So let's take a look. It says, tip, find the moles first, then convert to grams. And we can use the mole roadmap to convert to grams. So the first thing we're going to write down is 2.50 molarity or molar equals how many moles of sugar in 1.25 liters. So we're setting them up to be the same, and we need to know how many moles we're looking for. So I'm going to isolate the X moles of sugar. I want them all by themselves. So I multiply both sides by 1.25 liters. If I do it to the right, I have to do it to the left. And now they cancel out. I have moles of sugar isolated on the right. So now I just multiply 1.25 liters times 2.5 molar, and I get the number of moles. Now, the question didn't ask how many moles. The question asked how many grams of sugar. So now this is a straight up moles to grams equation. So that's where you start in the middle of the mole roadmap and go down to grams. So you write down what you were given, which was 3.13 moles. And then we usually do it with a straight line. You put the number of grams. You have to calculate the number of grams, C11, H22, O11, add them all up. That's approximately 330 grams. You put that on top. And then it's always 1 mole on these conversion factors. It's always 1 mole. And now moles cancel out and you're left with grams. And it would be 1,030 grams would be the amount of grams in the 2.5 molar solution. You're going to have a little bit of practice for this on our homework assignment tonight that's called Intro to the Mole and Molarity, and then we'll try some more problems with this a little bit later on. Let me know if you have any questions. That's it.